previous class, we looked at the beginning of vectors, okay, and we saw that in vectors, at least in the previous class, there are two very important things lah. Okay, number one is that we need to know how to count the magnitude of a vector. Okay, and we use Pythagoras theorem, okay, to help us to calculate the magnitude. As long as we know what is the length of the horizontal, okay, yang mendatar, and what is the length of the vertical, we can use Pythagoras theorem to calculate the magnitude of the vector. Okay, and just to remind you that any vector, okay, any vector, especially ones that are saying it like this, okay, like this one, okay, we can actually like split it up to become one horizontal and one vertical, so that we can calculate using Pythagoras theorem. Okay, and likewise, this red color one, this one that is moving down here, okay, we can say that it is to the right and then downwards. Or you can also say it is downwards and to the left. Sorry, did I say to the right? It's not to the left. To the left and downwards, or downwards and then to the left. Whichever one you want to do first, okay, it doesn't matter. As long as you can form the right angle triangle. And we can do this, we can do it either way, because it starts and ends with the same initial and final point. Okay, so any vector, you can actually split it into two components. Here is another one now. Let's say it is, let's say it's this way. Let's say this vector is this way. So you can, in order to calculate the magnitude, I need to know how much is it to the right, and then how much is it to the down, okay, downwards. Okay, or if I want to go downwards first, it's okay. Okay, downwards first and then to the right. Doesn't matter, because the starting point, the initial point, and the terminal point, okay, is the same point. So it doesn't matter which one you want to use, a green color one, you use a blue color one, doesn't matter. As long as you know what is the length, you can calculate the magnitude by using Pythagoras theorem. Okay, this is what we studied yesterday. The second thing that we studied yesterday was that if let's say I have a vector and I put a number in front, okay, so the number will tell us how much bigger it is or smaller, okay, than the original vector. Okay, so if it is a number that is bigger than 1, let's say example 3, like in this case 3. So if the original one is that is 3a will be 3 times of the original one. Okay. Secondly, if there is a negative number, like -1 or -3, the negative means that the direction is changed compared to the original vector. Okay, so whatever it is, we need to know what the original vector looks like. And then we can put the number, we can put the negative if we want, okay, to substitute, either change the direction now, or you know, change the length now. Okay, all this it can be done by putting in that number or the negative sign. Okay, so this direction thing is a very important thing, because that is what separates, that is what is different about vector compared to, let's say, like coordinate geometry. Coordinate geometry, you just count the distance, count it already. But in vector, the distance is important, but also the direction of that distance is very important. Okay, so the direction is a very important thing when we look at vector. Okay, so today what we're going to do is we're going to look at another part of a vector, okay, which is we're going to look at parallel vectors. Okay, parallel and non-parallel vectors. So here are a little bit of notes, okay, for you all. So let's say you have two vectors. Okay, you have vector u and you have vector v, and then I say that u equals to, I'm going to change this letter to the letter m. Okay, u equals to mv. Because okay, this letter over here that you see is lambda. Okay, lambda, but it's a little bit difficult to write. It's a little bit difficult to check if you want to type in the lambda. So I'm going to change it to letter m. Now, Let's say I have vector u and I have vector v, and then I say that the vector is equal. Okay, it's u equals to v, but there is a number in between there. It's m over there lah. Okay, then I can say if there is a number m. Okay, if there is a number m, then I can say that u and v are parallel. Okay, u and v are parallel. Now, if let's say I were to say that, like in this case lah, okay, hu equals to kv. Okay, notice that h and k are numbers, u and v are vectors. So if I say that hu equals to kv, if I 搬过去 if I pindah the h over, I will get vector u equals to k over hv. Okay? And we will still get the same conclusion. Okay, that vector u and vector v are parallel, okay, because m equals to k over h, which is what we get over here lah. So that number is equals to k over h. Okay, here's an example. Let's say 2u equals, sorry. Okay, u equals to 4v. Okay, now is it parallel or non-parallel? It's parallel because there is a number and it is equals. Okay, so m equals to 4, and according to our understanding over here lah. What if u equals to negative 4v? Is it parallel or is it non-parallel? Okay, the answer will be it is parallel. The negative sign just means that the direction change, but parallel lines will always be parallel because there's a number there. So maybe u is like this, and then v is like this. So these lines are parallel, although the direction is different, but the gradient is the same. Okay, so that's a very important thing. So whether the number is a negative number or positive number, okay, as long as you can get a number and we say that the u and v are equal vectors, okay, therefore we can say that u and v are parallel. Okay, so let's take a look at exercise 5. Exercise 5 over here. Now let's try not to show you the answer. Okay, so let's say that u and v it says are parallel. Okay, so how do I prove that u and v are parallel? Okay, so first of all, what you can do is you can take, if you look at this, half x, this is 1x lah, kan? Okay, 1. This is 3 over 2, then become 3, or 3 become 3 over 2. Okay, so one good way is you take the bigger vector first. Okay, you take the bigger vector. So I'm going to start with this one. V equals to x plus 3y. I know the example there is slightly different, but we're going to use this one now. Okay, so how do I change 1 to become half? I divide by 2 bahkan. Okay, either I divide by 2 or I times by half lah. Same thing. Okay, so let me factorize out the half over here. Half x. Sorry, divide by 2 means outside here I factorize by 2. Sorry, 2. Okay, so this one 3 divided by 2 will become 3 over 2y. Okay, do you see that? Okay, we take it out because we want to change the 1 to become half. So we have to factorize out the 2. Okay, so 1 divided by 2 is 1 over 2, 3 divided by 2 is 3 over 2. Then you see that this half x and 3 over 2y is actually vector u. So I can say that vector v is equals to 2 vector u. And then remember what I said just now? I said that if we have two vectors that are equal, and there is a number that connects the both of them, therefore u and v are parallel. Okay, as long as you can put in the u into the v, or you put in the v into the u, okay, therefore it will be parallel. Okay, in this example, what they did was they started with the half x lah, and then they wanted to change the half to become 1. They want to change the half to become 1. So they factorize out the half. You get 1 plus 3y, then this one is actually vector v. So you get half v. Okay, so I want you to let me do another one now. Let me do number 2. Number 2 is a little bit difficult. Trying not to show you. Okay, so number 2 is 3x and negative 5x. And then I want to see whether it's parallel. It's parallel lah. Okay, so what I can do is, if this is a single vector, that is easier. If it's a double vector, and just now, it's a little bit harder. But what you can do is, you can take the x and just leave it alone. So you move the negative 5 across, you get negative 1 over 5. EF. Kan? Then you substitute this into this one. Okay? Then what you will get is negative 3 over 5 EF. So BC equals to negative 3 over 5 EF. Remember what was the syarat just now? The condition is, as long as you can say U equals to V and there is a number inside. As long as you can find a number inside, then you can say that BC and EF are parallel. Okay, there are some certain situations where you cannot get a parallel one, but we're not going to talk about that. Okay, we are just going to try to prove that they are parallel vectors. Okay, so give number 1, number 3, number 4 a try. Okay, I'll give you about maybe 10 minutes to try to answer those questions, and then after that, we'll discuss them. Okay, the important thing is, when you have already factorize it out or everything, tell me what is the value of m. Okay, tell me what is the value of m that makes it parallel. Okay, 10 minutes 10 minutes. Let's give this a try. Okay, let's look at number 1 Okay, number 1, actually, we see it's 5 because the 10 and the 2, right? The 10 and the 2 actually is connected by the number 5, because 2 times 5 is 10. 2 times 5 is 10. So, or if you want to do like this method, also can. And let's say you have CD equals to 2x. So I put the 2 down here lah. So half CD equals to x. Now I put the half CD inside here. So AB equals to 10 times half CD. 10 times half will give me 5 CD AB. Okay, but now what if let's say I get another way lah. Okay, I don't want to put AB as the starting. I put CD. Also can. If you get the answer CD equals to 1 over 5 AB, this and this are exactly the same thing. Okay, it's just that your kepala, the thing that you put in front is different lah. But it's still the same. Is it same vector? Yes, it is same vector. Is there a number that connects this vector? Yes, there is a number that connects this vector. Doesn't have to be a whole number. It can be a fraction. It can be 1 over 5. Totally no problem. Okay? But as long as you can equate the two vectors and there is a number that connects the both of them, therefore they are parallel. Okay? All right, number 3, Stephanie says she got U equals to 4V. I think that's pretty easy. Okay, because we changed the 8 to 4. Change the 8 to 2 by factorizing out the 4. Okay, so you get this one. Okay, no problem. Okay, let's take a look at number 4. Number 4 is 4 and half become 24 and 3. So we have to do slightly different. Think about the 24 and the 4. 24 and the 4, the connecting number is 6, because 6 times 4 is 24. So 24 divided by 6 will give you 4. And therefore, 3 divide by 6, give you half. Okay, then you can put the x vector inside here. Put the x vector in here, you get y equals to 6x. Now the m equals to 6. Okay, so these are parallel vectors. So, it's a little bit of play here, play a little bit here, play a little bit there, try to maneuver it. You will be able to get the answer. Okay, it takes a bit of practice. Okay, don't worry. All right, the second thing that we want to talk about is this one. If two vectors, okay, are equal, okay, dia kasih sama dengan vector u equals to vector v, and then there's a number, hu equals to kv. But they say that they are non-parallel. They are equal, but they are non-parallel. Okay. Now, if this is the condition, then the conclusion is that this number is equal to 0 and this number k is also equal to 0. And the number k and h not necessarily is just one single number. Like it can be the whole thing, like it can be a whole sentence. But you need to know that the whole sentence is equals to 0. Okay, that's the most important thing. Let's take a look at the example. Okay, example 6. Now, so the question say, given two non-parallel and non-zero. So the question already say, u and v is non-parallel and non-zero. And then they say that u and v is also equal. Oh, okay, so we think about the condition. The condition is u and v is equal, but u and v is non-parallel. Okay, they're equal but non-parallel. So the conclusion is that this whole thing is equals to 0 and this whole thing is also equals to 0. It's a very simple concept. Okay, very simple concept. Don't make it complicated. The whole thing equals to 0 because already given to you the condition already. Same equal vector, they kasih sama dengan, but they are non-zero, non-parallel. They just non-zero, non-parallel. So kasih equals to 0, you can find the value of h and you can find the value of k. Okay, this set of exercises is much simpler than the exercise number 5 just now. That was a little bit more difficult. So I hope that you all can try to do this. Okay, so everyone, question number 1, number 2, number 3. I'm going to give you another 10 more minutes to answer this. And then I'm going to call 3 different people to give me the answers to this. Okay, number 1, number 2, number 3 in exercise number 6. Okay. All are non-zero, non-parallel vectors, but they are equal. All right, 10 minutes. Let's take a look. So Yvonne said that h equals to 0, k equals to 3. K equals to negative 3. Okay, good, excellent. See, very easy, right? As long as you know that it is non-parallel, non-zero, you can equate it with 0. Okay, not a problem at all. Okay, number 2. H equals to 2 over 3 and k equals to negative 4. Okay, so don't forget, if it's negative 4 over 1, make sure you finish the answer. Okay, don't leave it as negative 4 over 1 because it can still go into negative 4. All right, now let's look at Zhonghan's question. So Zhonghan just now said that h equals to half. Okay, h equals to half is correct. Negative half, sorry, negative half. That's easy. But look at the right side. Okay, the right side, it says, I'm purposely not showing you yet. Okay, so the right side says k squared plus 2k minus 3. Then 我们讲 is equals to 0. Okay, we're saying that it's equals to 0. Now, whenever you see this, and then I say find the value of k, what do you think I should do? Anybody in this class? Can you give me a suggestion? How do I find the value of k if it is like this? Correct. This is a quadratic equation. So we use EQN. Okay. So Zhonghan, we learn from here okay, whenever you see quadratic square, and then sama dengan kosong, and then we want to find the value of k, is no more punkochi lah. It's no more pindah. Okay, we use EQN. Okay, very good, Charlotte and Sinbury. So when you use EQN, you will get the answer k equals to negative 3 and 1. Don't forget to put the bracket. Okay, negative 3 becomes plus 3, 1 becomes minus 1. Okay, this one must put. Okay, Zhonghan, I hope that this is clear. Don't forget and the rest of you as well. Okay, doesn't mean that just because it is k squared means you still 不过去 lah. We still remember the things that we have done before. Quantity equation, we use EQN, and so on and so forth.